Hello. Welcome to our live session once again. Apologies, we failed to have it earlier when we planned for it. So we're going to give people a minute or two to join in on the lesson and then we can start. Okay, so kindly help me by typing up your name once you manage to join in on the live session so that we know who is with us. I can see Naomi is already here. Okay, anyone else, just quickly type up your name so that we know who is with us and who is against us. Okay, so apologies, network has really been so bad, but I pray we get through this lesson without too many issues. Okay, so for those that have joined, quickly type up your name so that I know who is with us. Type up your names, type up your names. So I want us to continue where we left off with physics so that we can make some progress. So the last time we met, I defined a vector quantity and we focused more on the direction referring to a particular angle. Okay, so we said all angles, so just a quick recap. So we started by defining vectors, and we defined a vector as a quantity having both magnitude and direction. Okay, so the magnitude refers to how much we have, and then the direction refers to the angle. Then I said there are two angles that we use in our studies, and those angles could be radians or they could be degrees. So radians in physics are not relevant. Our focus will just be degrees. Okay, so Taisia, welcome. Type up your name for those that have just joined us. So we're going to focus on degrees. Now, there's a certain way to read angles. How do you read an angle? Okay, so to read an angle, all angles are read from the positive x-axis in an anti-clockwise manner in this direction. And there are certain angles that are standard. For instance, this is 0, this is 90, this is 180, this is 270, 0 is also 360. In between 0 and 90, we're going to have, 0 is also called east, 90 is also called north, 180 is also called west, 270 is called south. Yeah, so in between north and east, this is going to be northeast, and it is going to be 45 degrees. Just a quick recap. Between north and west, that would be 90 plus 45, that would be 135. That would be northwest. Next, between south and west, we're going to have southwest. That's going to be 180 plus 45, so 225. Between east and south, that's going to be southeast, and that's going to be 315 degrees. So these are a few standard angles. Yeah. Okay. So yeah. Let us now talk about components. So Caleb, welcome. Simata, welcome. Taisia, welcome. The others that have joined us, kindly type up your names so that we know who is with us. So the next part is us looking at components. So I need you guys to pay attention to what we're going to start to talk about. Because the moment you miss this, it will be rough. Very rough. So components. So a vector can be resolved into two components, comma, the x and the y. So what two components do vectors have? Just start up x and y. I need to know that we are all moving together as one. What two components do vectors have? Just quickly type up x and y. I need to make sure we are all moving together. Quickly type up x and y. Mono, welcome. Samuel, welcome. I know network is bad, so please bear with us. So we say the two components that we have are the x components and the y component. So now, how do these components come up? So let's start by drawing a vector. So a vector, we said, has a certain magnitude, and that magnitude we're going to call it r. Okay. This magnitude has to be at a certain angle, and this angle we're going to call it theta. So if we play around with the things, we said a vector is going to have two components, an x component and a y component. So if we were to draw an axis here, this will be our x, this will be our y. So to move from the start here up to the end, you could either go directly if you're moving along a certain angle, or you could move a certain amount in the x, which we call the x component. And once you move a certain amount in the x, you then move a certain amount in the y, which we call the y component. Okay, so a vector has two components, and components are just an alternative path. Instead of going directly from the start to the end, you move along the x, which we refer to as the x component, and you move along the y, which we refer to as the y component. So if you pay attention, we've ended up with a right-angled triangle. And right-angled triangle, what mnemonic did you use in grade 12 to relate the sides of a right-angled triangle? Let me just label these sides. So this would be the opposite, this would be the adjacent, and this would be the hypotenuse. There's a mnemonic that you people used to use in grade 12 to relate opposite, adjacent, hypotenuse, and the angle. What mnemonic was that? You people recently left grade 12, so I know these things are just on your fingertips. What mnemonic were you using? I'll give you a hint. It starts with S. It starts with S. And it helps us with the three common ratios under trigonometry. What mnemonic is it? Okay, so Brother Paul tells us SOHCAHTOA, Samuel tells us SOHCAHTOA. Anyone else? Ladies, participate. Participate. Okay, Mono tells us SOHCAHTOA. Good. So that SOHCAHTOA is what we're going to use. So now, SOHCAHTOA. Okay, so let me expand the S. So S is going to be sine theta. So the angle we said we'll be calling it theta. Sine theta is equal to the opposite divided by the hypotenuse. Cos theta is going to be equal to the adjacent divided by the hypotenuse. And the last one, tan theta is equal to the opposite divided by the adjacent. Now, tan is not used when you are splitting a vector into its components. The only things you're going to focus on are sine and cos when splitting a vector into its components. So now, we go back to our right-angled triangle, and our right-angled triangle was like that. This is theta. The opposite was what we called the y component. The x component, we labeled it as the adjacent, and the resultant, we labeled it as the hypotenuse. So, sine theta is equal to opposite divided by hypotenuse. I plug into sine, and this is going to give me, so the opposite is y component. The hypotenuse is this resultant. So this is going to give us sine theta is equal to our opposite being y component divided by our hypotenuse being r. All we have to do now is make the y component the subject. So if we cross multiply, this is as good as over 1. Y times 1, that gives us y component divided by r sine theta. So that is the first formula that we use to divide a vector into its components. So y is equal to r sine theta. Y is equal to r sine theta. Mr. Gideon, welcome, and I hope you are okay. As it is showing, Gideon has been with us on this page for 3 years. So these are veterans. Okay, next, cos. We said tan is not relevant. So cos theta is equal to adjacent divided by the hypotenuse. So that's going to be cos theta is equal to, our adjacent, according to the triangle, is the x component, divided by our hypotenuse is r. This is as good as over 1. We cross multiply, and it will give us the x component is equal to r cos theta. So these are the two formulas. But as a way to simplify them, just type up y is equal to r sine theta. You can use capital letter Q for theta. And the x is equal to r cos theta. So quickly type these two things up so that I know that you guys are following. Okay, quickly type up y is equal to r sine theta and x is equal to r cos theta. So network is so bad. Let me see. I hope it won't misbehave. Okay. Yeah, so I'll switch to a different network. Hopefully this one will treat us better, unlike your ex. Okay, so Taizia has typed. So y is equal to r sine theta and x is equal to r cos theta. Please master those. So these two are used for splitting a vector into its components. So under this topic, you need to know how to split. And once you learn how to split, you then need to know how to put the vectors back together. Okay, fuma ima. Okay, so let's go. Next, so all this is used for splitting vectors into components. Okay, so let's do some example. We see how it goes. I hope you guys have your calculators. So let's assume we have a certain vector. R is equal to 100 newtons and it is acting at an angle theta is equal to 60 degrees. So we said the y component is found as r cos theta. Is this correct? If I claim the y component is r cos theta, is this correct, yes or no? If I claim the y component is r cos theta, is this correct? Okay, so Mono says no. Let's see what other opinions we have. Ish, my Bantu network is pathetic. Okay, so this is wrong. So the correct one is the y component is equal to r sine theta. So all we have to do now is just plug in our r and plug in our theta. So the y component for the vector shown above, the resultant is 100 sine 60. Those of you with calculators, what will 100 sine 60 give us? What will 100 sine 60 give us? What will 100 sine 60 give us? Quickly. So apparently the network we've connected to is equally misbehaving. This is bad. Real bad. Michael. Anyone with a calculator, what is 100 sine 60? Fast. 100 sine 60. What will 100 sine 60 give us? I hope you guys are able to hear me. 100 sine 60 more pekale 86.6. Oh yeah, but don't put degrees. Don't put degrees. The degrees is just for the angle. So 100 sine 60, because the 100 was newtons. So the final answer, the y component, will actually be 86.6 newtons, not degrees, newtons. Okay, let's do the other one. The other one will be the x component. So the x component will be r cos theta. Fine. So you plug in, that's going to be 100 cos 60. 100 cos 60, what does it give us? Abraham with an H. Senior student, how are you? How is life? How is the wait for results? Alright, so what is 100 cos 60? What does 100 cos 60 give us? And please, as you guys buy your calculators, avoid buying your calculators from places like Zambia. Calculator that you can't pronounce. Okay, so Samuel tells us this will give us 50 newtons. Excellent. So now you guys know how to split vectors into their components. Now let's learn how to put these vectors back together. The tension is there, but it's alright. Tension is problem with what sungu babla. Anyway, so we can now go to combining vectors. So the two formulas used for splitting are y is equal to y is equal to r sine theta, and x is equal to r cos theta. These split a vector into its components. Now, if you've been given components and you're asked to combine them, this is the formula that you use. Remember, under SOHCAHTOA, we could only use sine and cos. We couldn't use tan for splitting, because tan finds its way under combining. So when combining, we use two things. Number one, we use r is equal to square root of the x component squared plus the y component squared, and then everything under a root. That's how you find the resultant from the components. And then to find the angle, we use tan theta is equal to ry over rx. So these are the two formulas that we use. This for finding the resultant. Remember, we are looking for a vector, and the vector is supposed to have both a resultant and an angle. So the resultant, if you've been given components, is this. The angle, if you've been given components, is this. So let's see if we can combine these two components that we had earlier to see if we will get back the original vector. So let's phrase it as a question. Let's phrase it as a question. A vector has x component being equal to 50 newtons and the y component being equal to 86.6 newtons, comma, find the magnitude and direction of that vector. Find the magnitude and direction of that vector. So sometimes they won't even add the word magnitude and direction. They'll just say find the vector. And from the definition of vectors, you're supposed to remember that vectors have both the magnitude and a direction. So the resultant will be the x component squared plus the y component squared, then under a square root. A more refined one here can be r is equal to resultant x squared plus resultant y squared, everything under a root. They are the same. Right now you are just learning the basics, so I'm keeping it as simple as possible. So let's plug in the values that we have to find the magnitude. So the resultant here is going to be square root of, our x is 50, so that's going to be 50 squared plus 86.6 squared. Now, because of rounding off, we might not get the exact answer, but it should be close. So let's try 50 squared. So 50 squared plus 86.6 squared. So under the root, it's giving us 9999. So this becomes r is equal to square root of 49.56. Okay. Then we find the square root of the answer. I hope what I'm typing in the calculator is visible. So square root of 1234.56. Okay, and the square root of that giving us r is equal to 99.9977 blah blah blah. If round this off, this is basically 100. Now, if they asked us to find a vector, are we done by just finding the resultant? And what is missing? We found the resultant, but the question asked us to find the vector. So what's missing? Quickly type up what is missing. Quickly. What is missing? We found the resultant, but for it to be a complete vector, something is missing. So what is missing? Okay, so Samuel says the direction or angle. Good. And what trigonometric ratio, sine, cos, or tan, do we use to find the angle, according to what I have described so far? What trigonometric ratio, sine, cos, or tan, do we use when finding the angle? What ratio do we use when finding the angle? What ratio do we use when finding the angle? Yes, direction or angle is missing, but what ratio? Is it sine, is it cos, or is it tan that we use when finding the angle? Okay, excellent. We use tan. Okay, so to be more specific, recall that tan theta is equal to r y divided by r x. Now, don't just use tan munguru munguru. Always sketch the resultant y and the resultant x. So we were told that the y component is 86.6. And we were told that the x component is 50. So both of them are positive. So if we were to sketch these on an axis, up we are moving in the positive y. Down we're moving in the negative y. To the left we're moving in the negative x. To the right we're moving in the positive x. Okay. So now, following this, moving up, in the x we're going to move to the right, 50 units. So we move 50 units here. So that is positive 50. On this diagram, only write the positive forms of numbers. If it had a negative, the negative would only imply the direction as to either left or down. But you still just write it as 50. Okay. Then the other vector is we're going up because it's positive in the y. So up is 86.6. So the resultant is always in between the two vectors given. So we expect the resultant to be here. And the angle that you want, standard angles, where did we say we should strive to read all angles from when dealing with vectors? What is a standard angle? An angle that has been read from where and in what direction? Quickly, what is a standard angle? Where do we read standard angles and in what direction do we read them? What is a standard angle? Where do we read them and in what direction do we read them? Okay. Quickly. Standard angle. Okay. Standard angle. Standard angle. Standard angle. Okay, excellent, Timothy. So Timothy says positive x-axis. So we read it from the positive x-axis, good, in an anti-clockwise direction. Samuel says from the positive x-axis in an anti-clockwise direction. And Mono says positive x-axis, Moape from the x and read it in an anti-clockwise, Mono, anti-clockwise direction. Good. It shows you guys are getting, yeah. So the standard angle here, according to the sketch, will be this. Now, I need you to understand that tan always gives you an angle, gives angles that touch the x-axis. So what do I mean? Anytime you use tan, expect that one of your angles will be like this. So if you use tan, you expect it to give you this as an angle, or this as an angle, or this as an angle, or this as an angle. So anytime you use tan, tan will always give you an angle that touches either the positive x-axis or the negative x-axis. Generally, the angles for tan always touch the x-axis. Okay, so in this case we are lucky because the sketch, the angle we want is this one. So using tan directly will give us the angle that we want. Remember, tan theta is equal to Ry divided by Rx. So tan theta is equal to, my Ry is movement in the y. So in the y it's 86.6, in the x it is 50. Okay, so theta is equal to tan inverse of 86.6 divided by 50, depending on what your calculator can do. Okay, so shift tan inverse of 86.6 and then everything divided by 50, then we close. I hope this is visible. Okay, good. So what will this give us? Okay, so this gives us 59.9999, which is essentially 60 degrees. And the 60 degrees is being read from the positive x-axis. So to fully describe our final vector is 100 newtons at 60 degrees with respect to the positive x-axis. Yeah. So this whole topic can basically be summarized in 2 parts. What are the 2 things we need to be able to do to vectors? So under vectors, we need to know how to split a vector and how to combine a vector. So once again, I want you guys to give me the 2 formulas that we use to split a vector into its components. What formulas do we use to split a vector into its components? What formulas do we use to split, and what formulas do we use to put everything back together? Quickly. First, what formulas do we use to split? What formulas do we use to put everything back together? Yeah. This is the only way to make sure you guys are following. Otherwise, I'll just find myself talking to myself. Is network bad? People can't type. It's just taking a while to type. Okay, so Mon tells us x component is r cos theta, y component is r sine theta. Excellent. So to split, the y component is r sine theta and the x component is r cos theta. And this theta, you always make sure the angle is read from the positive x-axis. Then to combine, we need to find the magnitude and then we need to find the direction. So magnitude, we're going to use r is equal to square root of rx squared plus ry squared. And then the angle is going to be tan theta is equal to ry divided by rx. And remember, tan always gives you an angle that touches the x-axis. So anytime you use tan, remember the angle is going to touch the x-axis. So basically, this is where our lesson ends. I'm taking this slowly because we're not in any rush. I need you guys to understand these basics very, very well, because if you don't know how to split a vector into its components, it will be a bit rough. So let me see if I can show you guys some past papers. Okay, so that you see how some of these questions come. Okay, so physics test 1. Okay. Is there anything close by? I can't seem to find what I wanted to show you. I can't seem to. Anyway, so some applications of vectors will be a question such as this. Sorry, let me switch this thing off so that you're able to see. Okay, so this is how a setup will come. So how do we know that we're dealing with vectors? As you can see, we have some forces that we're calling tensions, and we have angles. So we have magnitude and we have direction. So to handle this question, basically you need to use vectors. You can't run away from vectors. This is another question requiring an application of vectors, though it's deeper than what we've done, but this is where we are getting to. Let's see if there's anything else. You can't run away from vectors, my friend. You can't. Yeah. Anyway, so roughly that. Okay. Have a good day. I will see you again at 21. We're going to do something in math today. Bye-bye.